something against Atlantic, it can be held against me in the court of law. All right. Anyway, so I do have the homework. So if you have to get out of class, I need to write down your scores before I give them back. But I also, Jordan, did you happen to check email or not?
Yeah, no, I got it.
Okay, so is that something you'd be able to get back to me at some point soon?
Like hand into you, like in person?
No, I just need to scan back.
Oh, okay, yeah, I could do that.
It's that easy to do. I don't have to get your signature if I say why I didn't get it, but everybody else has to sign there, so. Actually, you want to be careful, touch it, or you would not? You got to sign it and give it back. Give me your autograph. Basically, it says if you don't sign it, you get an F, and I would have to go change your grade. I don't want to do that. I gave you all incomplete because I was supposed to cram stuff down your throat and be done by around December 18th on my birthday. Remember that? Where's your pen, dude? I don't know. All right, here, I'll give you this. It's fine. It's fine. Yeah, I don't care. I'm just going to scan it tonight. But you can use a pencil. Today, no, don't date it today. Date it the 18th. It's December 18th, 2020, my birthday. Apparently I was supposed to do that. So just put the same date that I had on there when you do it, okay? 12/18/2020, everybody good?
Are we doing something on Monday?
I'm not planning on it. I'd like to do something fun on that day, but I don't know what's going on. Is there a game that night?
Yeah,
What day?
Monday the 18th. When we don't have school, there is a game.
Next week, we have 3 games.
Who do we play to do in the school?
We play Denny or Grandview next week in Glenwood.
Red Oak in
Okay. Well, we'll figure it out. So like I said, I've got the keys are open. I will get your homeworks to you today. Don't leave without your 3 homeworks, but I got to write your scores down. So let's just go over this. Maybe there'll be something I can have you work on while I write the scores down anyway. But we were looking at x cubed. We're looking at area under the cube, under the curve, right? And so we're going to split up and use a bunch of rectangles and then add those rectangles, the end rectangles that we have underneath. We're going to add them all up, and that's going to get close to the area, right? That's what we're really trying to do here. And then what we really know is that it's base times the height. The base is delta x, so that's the area of the ith rectangle, which is just any one of them in there, right? But if we have the same width for all n rectangles, we can just take the right endpoint minus the left endpoint and divide it by n, right? And that would be the base for the width. So delta x does have a formula b minus a over n if we're looking on a closed interval from a to b. So with that being said, in this case, since we were going from 0 to 5, the delta x is 5 over n. Okay. Now, since we said instead of base times height, we're going to write it as height times base, because usually the delta x or the dx in the antiderivative is last. So I just kind of reverse the order because of the commutative property of multiplication. But anyway, what we have is x sub I minus 1 quantity cubed. So we need the left endpoint is the one that hits that curve. And so what we really have here, the area of the ith rectangle is x sub I minus 1 quantity cubed times delta x. And then we're gonna add those up. So the biggest thing is we really have, if I plug in 5 over n, then this becomes x sub I minus 1 quantity cubed times 5 over n, right? But the problem with that is how many variables do we have? Three of them, right? X is a variable, I is a variable, and N is a variable. So we don't like that. Now, N could be given because I could say, hey, let's do 10 rectangles, right? So N is going to be given. So that's not a problem. But the X is a variable and the I is a variable. So what we really want to do is we want to take this value and we want to write it in terms of only I. Okay, so we want to write it in terms of I. Isn't that what I did on my videos? Okay. Now the problem is, I started with a hard one because it's X of I minus 1. I think I started with a hard one. But anyway, what would the approximate area be under the curve here? And you can see it okay, Jordan, I assume, the board? Okay, what would the approximate area be? The approximate area would be, so squiggly equal sign, the sum I equals 1 to n of a sub I, right? The area of the I rectangle. If we add up all n of them, all n of those rectangles, that's going to be the approximate sum, right? And so that's going to be close to the area. Of course, we know we're leaving some out on the top side here with inscribed rectangles in this case. So our area is actually going to be a little bit too small. So we're going to let n get bigger, right? So what do you think? If n gets bigger and bigger and bigger, what did I say from chapter 2 that we're going to use then? So the true area is going to be the limit as n goes to infinity of the sum I equals 1 to n of the a sub i's, right? So that's going to be exact. So if we take the limit as n goes to infinity of that, we're going to be good to go, right? And then we're going to use those formulas. All right, so the whole challenge now, all we have left, we did the work yesterday, we just got to figure out what x sub I minus 1 is. Like how far over it is. I don't want it in terms of x sub I minus 1, I want it in terms of i's, right? If I remember how to. So can I erase? Let me see what I can erase. Everybody good on this? Base times height. We're good here. I'm just going to leave that last part there. Okay. So how can we do that? What do we do in my videos? How many delta x's over are we? Isn't that what I said? How far over are we? So we're starting at 0, so that's good. So basically, for the first rectangle, that's a sub 1, right? Which endpoint do I want? I want the left one, correct? And it's just, and it'd be a no area, right? I know it's going to be no area because I have no height there, right? But anyway, what is the left endpoint? So yeah, in this case, I minus 1 is 0, right? So this is x of 0. Anyway, that equals 0, right? For the second rectangle, so that basically there's no delta x. For this one, I'm over no delta x, right? I didn't go right by a delta x. The bottom part, the width is delta x, right? But I don't have to go over any to hit my endpoint, correct? All right, what about the second rectangle? How many delta x's is it? 1 delta x. So 1 delta x to the right gives me the second rectangle. What about the third rectangle? 2 delta x's. What do you notice about the subscript versus how many delta x's there are? It's going to be one less. So if I say for a sub I, What's the left endpoint? By the way, this is the left endpoint. So I didn't really write that out, but x sub I minus 1 is the left endpoint. Is how many delta x is over?
Whatever number it's on.
Wait, the ith rectangle, oh wait, ith rectangle. It's gonna be I minus 1 delta x's, right? Sorry. If this is a sub I, sorry, this is a sub I is the ith rectangle, right? A sub I is the area of it. But anyway, for the ith rectangle, the left endpoint is gonna be one less delta x's than the number of the rectangle, which is I, the ith one. So it's I minus 1 delta x's over for the left endpoint, right? For the left endpoint. Now what's delta x though? So this x sub I minus 1 is going to equal I minus 1 times delta x, right? We're trying to figure out what x sub I minus 1 is. So for the ith rectangle, it's the left endpoint, right? Which is one less than that number of delta x's, okay? But what's delta x? What's delta x? If I have n rectangles. It's b minus a over n. But in this case, for this problem, it's 5 over n, right? Okay, so that's x sub I minus 1. So then what are we going to do then? So this is x sub I minus 1. What I can do is I can plug this in right here. Everybody agree? Because that's going to be the left endpoint. That's going to be, this is going to be the area of the ith rectangle. And then what I'm going to do is I'm going to take the limit as n approaches infinity of the sum of those areas from 1 to n. Okay? That makes sense? All right, so let's do it. Can I erase this now? Give myself some room. All right, like I said, with a cube, it's not going to be quite so easy, but that's all right. Anyway, I just had to figure out that endpoint, like how many delta x's over it was. All right, so what's a sub I? Let's go back here. A sub I then is going to be the area of the ith rectangle is going to be I minus 1 times 5 over n quantity cubed. And then times 5 over n, right? For delta x. So this is x sub I minus 1, quantity cubed, times delta x, right? So let's go ahead and cube this out. But what I really want is I want the i's together, and I want the n's together. So if I cube a product, I just cube each part, right? So this is 5 cubed over n cubed times 5 over n is like 5 to the 4th over n to the 4th. What's 5 to the 4th? 625 over n to the 4th, right? Times I minus 1 quantity cubed. Everybody agree with that? So you good with that so far? Yeah. Okay. So what do? I got to cube that out, right? So it's 625 over n times, if you cube this, what is it? It's I cubed, and then you alternate minus I squared plus I minus 1. Is that right? Yes, thank you. Is that right? Did I cube that out right? Pascal's triangle. 1, 3, 3, 1, oh, 3. So it's 3 times I squared and then times 1 to the 1st. And then 3 times I to the 1st 1 squared, and you alternate the signs, and then it's the 1 cubed, but I alternate signs here, right? Isn't it minus first? Anybody want to verify that? It's I, if you square it, it's I squared minus 2I plus 1, right? And then times I minus 1 again. So it's I minus 2I squared, but then I'm going to get a minus I squared is minus 3I squared. Yeah, so that's right. That should be right. Anyway. Okay, so we got that, right? This is the area of the ith rectangle, and that's in terms of only n and I. But now, n is given, like if I said, hey, let's do 100 rectangles, or let's do 10 rectangles, that's given, right? And then so we have this. So really, now when I get to the area, the true area then is going to be the limit as n goes to infinity of the sum I equals 1 to n of base 5. You got to do that in this section, or am I getting ahead of myself?
You do it in your video.
Okay, that's in this section.
Yeah.
Yeah, that's okay. Good. So anyway, what's the area going to equal? It's going to equal the limit as n goes to infinity of the sum I equals 1 to n of this thing, right? Of 625 over n to the 4th times I cubed minus 3i squared plus 3i minus 1. Everybody agree with that? Now we have formulas for the sum I equals 1 to n of things in terms of I, don't we, that we did yesterday? And I said you need to know them up to the cubed. I don't really know the 4th one, but we have that box that you can look at. By the way, just so you know, so I know Jordan was asking because she's not sure on time frame yet. If you do, we'll talk. But anyway, here's what I will do, guaranteed. I will let you on your comprehensive final exam use 1 sheet of paper, front and back, write anything on it you want. If you want to start writing stuff out for review or chapter 4 stuff or whatever you want, or certain examples, or the derivative and antiderivative trig functions on there, I don't care. You can write as small as you want, you just can't copy somebody else's. And just a computer sheet of paper. So I wouldn't even use one from your notebook because that's smaller than a computer sheet. 8.5 by 11 both sides, write as small as you want. I will guarantee that I'll let you use that on your test. So I know that, and I guarantee you have a comprehensive final. Those are 2 things that I know. Besides that, I'll figure it out. Okay, is that enough warning?
Do we take this section 4 test separately? Or together?
Well, the way I normally do it is I have a half of the points is going to be 200 points, so it's double test. So, I mean, like usually I get a 2 or 2.5 hour block. I don't get that with you, right? So we're going to have half of it. My thought is we're going to have half of it Thursday, the other half Friday, but then that doesn't leave any time for fun or review, right? That's what I don't like. But
You know when we're going to take our test?
tentatively Thursday, Friday. Yeah, but I need to get through some other stuff in chapter 4. That's what I need. So I want to make sure that I don't shortchange you. You have my videos, but like I want to go through stuff with you too and make sure that you're okay with it. Anyway, so let's do this. So what can we do here? What can I do with that 625 over n to the 4th? I can actually pull that out in front. Why? Because n is given, so n is a constant, right? N is just a number. Okay, and it doesn't vary. It's not, in other words, it's not a variable, even though it could be any number. I is the variable here. Okay, I is the one that varies or changes. So anyway, I can pull that out front, and then I can actually do that for each part, right? So this is, anyway, this is going to be the limit as n goes to infinity of 625 over n to the 4th times the sum I equals 1 to n of I cubed minus 3i squared plus 3i minus 1. Now, here's what I want you to do. I want you to calculate what this sum is first, and then we're going to multiply it all through by 625 over n to the 4th, and then we're going to take the limit. Okay? But to do this, we're going to do this in teams. So I'll do the last one. I want you you two and Luke to do the sum of I cubed. And I want you two in the back and Jordan to do the sum of, we don't need the minus, just 3i squared, one to n. And that's using the formulas from yesterday. And then I want you two over there to do the sum I equals 1 to n of 3i. Okay, and make sure you agree. I'm going to give you a couple minutes to do that.
How do you want us to do this with Jordan?
Well, Jordan's gonna have to do it on her own, I guess.
Uh,
You want to talk to him? Sure. Shouldn't take that long.
So,
You understand what I'm asking you to do?
I don't.
Yeah.
Wait, we have this one, right? Okay, thank you.
no,
We don't?
no, we have 3i squared.
Oh,
Professor Al, we have 3i squared, right? Our group has 3i squared.
Sum I equals 1 to n of 3i squared.
So what is it?
John, how do we do this if we don't know n? How do we do this if we don't know n? N. That doesn't make any sense. Well, 'cause I put the 3 out front, so that cancels with the 6 and the 2, right?
Oh, does it? Oh, I didn't put it with the end. I put it out like that. Just did that.
Oh, yeah.
Do you do it like that? Okay.
Is it the antiderivative? So, there she goes. Did you guys figure it out? Probably do now. You ever saw the videos? Did you understand them?
I'm like
Kinda.
trying to look on his notes online, but like,
Mhm. What's wrong?
oh, nothing. I said I was trying to look on his notes online.
It's just the formula, right? Like I squared is
That.
Yeah.
n times n plus 1 times 2n plus 1 all over 6 and then times 3, right? That's it. I mean, it's just that easy. I mean,
Oh, that's all it is?
It's nothing hard.
Oh, okay.
Oh,
We just
I didn't know
want these
Uh-huh.
to
okay.
finish the process.
It seems like you do pull out the 30.
Yeah, that's all we've had.
So then what did you guys get?
I got
I just need that piece.
All the
I
act-
think we're good.
probably
Good to go.
n times n plus 1 times 2n plus 1 over 2. All over 2.
Okay.
The keys, I just handed back. You good?
Yeah.
Yeah.
Okay, that's right. So I just handed back, and I got yours, the 4.1 through 4.3. I'll hand back chapter 3 Monday, I hope. But anyway, all of your, so I've got your points on there, so you can keep those. But the keys are available in Blackboard, DMAC, Blackboard, course content, chapter 4 folder, right? So you can at least look over those, do that for sure. All right, so now I'm gonna come back up here and see what this equals. So this is, it's gonna be the limit as n goes to infinity of 625 over n to the 4th times whatever you got. So what did we get for the first one? I cubed. That's just the formula, right? I mean, it was that easy.
Yeah.
So what is it? N times,
N squared plus n.
did you multiply that stuff out or not? I kind of wanted you to multiply that part out. Did you do that?
Oh, yeah, yeah.
Okay, give me the multiplied out version, because I'm gonna divide everything by n to the 4th.
N to the 4th plus 2n cubed plus n squared all over 4.
All over n to the 4th?
4.
All over 4, right. So n to the 4th plus 2n cubed plus n squared. So that's the formula that's in that blue box, and you just multiplied out the numerators together, right? Perfect. And then what? Minus whatever you guys got.
2n cubed, 2n cubed plus 3n squared plus 9 all over 2.
Okay, and then plus 3 times, or plus what? What's the next group got? Your- And then plus or minus, the sum 1 to n of 1 is n, right? Isn't it? So I did that one in my head. I know, really cool. So it's 1 times n. But anyway, so we have this, right? So ultimately what I want to do then is figure this out. So do I want to get a common denominator, or what do I want to do? I could do that, right? Can I erase this stuff? So I'm going to take the limit when I'm done. So I'm going to erase this. How much time I got? Okay, I got a little time, so I don't have to hurry too much. But anyway, to get the exact area, I need the area for n of them, which is just it. Now it's all in terms of n. I'm going to go ahead and get a common denominator though. So it's 625 over n to the 4th. Remember, leave the limit on there until you take it. So that's going to stay on until the bitter end. Anyway, but this, if I have 4, so it's going to be 4n to the 4th. 4 is the common denominator, right? Oh, I don't need that. I'm good. What would this one be? To make this a 4, that would be, yeah, 4n cubed plus, double it, right? 6n squared plus 2n. So I'm going to subtract that whole thing, which really means add the opposite. So I'm going to do that. And then this would be 6n squared plus 6n, right? And this would be minus 4n over 4. Everybody agree? So here's what I'm going to do. I'm going to go ahead and add or subtract on the top and put it all over 4. Okay? So I'm going to deal with the biggest power first, is n to the 4th. How many n to the 4th do I have? Just 1, so it's n to the 4th. Right? So I'm going to cross it out when I'm done with it too. And then I've got n cubed, so I've got plus 2n cubed minus 4n cubed is minus 2n cubed. And that's all I got for n cubes, right? Okay, and then I've got for squareds, plus n squared minus 6n squared is minus 5n squared. Plus 6n squared is plus n squared, right? Okay, and then for the n's, I've got minus 2n plus 6n is minus 4n.
Plus 4. Oh, wait.
Plus 4n, thank you, minus 4n goes away, right? And it's all over 4, so we have this. So what's really nice about this is I'm going to rewrite this a little bit. So now it's going to be, and remember the true area is this limit. So this is the limit as n goes to infinity. What I'm going to do is I'm going to bring that 4 out, and I'm going to put the end of the 4th in there. Okay? So I'm going to write it as 625 over 4 times n to the 4th minus 2n cubed plus n squared all over n to the 4th. Well, how do you evaluate limits at infinity? We kind of skimmed over that briefly, but basically I could divide each part by n to the 4th, right? Okay, so if I do that, so I'm gonna write this out so you can see it since I have a little time here. 625 over 4. So basically, a plus b plus c all over d is a over d plus b over d plus c over d, right? So this is going to be n to the 4th over n to the 4th, which reduces to 1, minus, and 2n cubed over n to the 4th is minus 2 over n, right? And then plus n squared over n to the 4th is 1 over n squared. Everybody good? Now, the question I have is what happens when you let n go to infinity? If n goes to infinity, what's 625 over 4 go to? It doesn't change, right? It's the same, it's constant. But if you let n get huge, what's 2 over n go toward? 0. So basically, now if I let n go to infinity, this one, I just draw an arrow up through it, goes to 0. This one, 1 over n squared, 1 over something huge squared, it's going to go to 0, right? And what do I end up with? 625 over 4. 625 over 4 times 1, right? And what would that be? That would be
156.
right, which you can do it that way if you want, but anyway, this is square units. I don't know what the units are, but it's square units. But that's the exact area under that curve. Isn't that awesome? Now I'm going to give you a little hint in case you watch videos ahead. The way we're going to do that with a definite integral is a definite integral from 0 to 5 of x cubed with respect to x. We know how to take the antiderivative of x cubed, that's x to the 4th over 4, right? And instead of putting a plus c, the fundamental theorem of calculus says we can evaluate that from 0 to 5. So I plug 5 in, figure out what that is, minus plugging 0 in, figure out what that is. So that equals 5 to the 4th over 4 minus 0 to the 4th over 4, which ends up being 625 over 4. Which way is easier?
When?
The second way. But it comes from this section, right? I know, it's awesome. So this is the fundamental, second fundamental theorem of calculus or something like that.
What's the point of learning that?
Theory, same reason you learn the difference quotient for derivatives. It's easier to just take it with, this resulted because of this theory here. Now you're not doing all the theory, but you're doing some of it. You're doing what I'm asking you to do in section 4.4 of it, and then we'll go on So next week will be better, but you gotta get this stuff. Now, reach out on this stuff if you got questions, or as you're working it out, you stuck somewhere, okay?
Thank you.
Have a good weekend, good luck tonight. Okay. You good, Jordan?
Yeah.
Okay. All right, and then, and you do or don't have dates?
I do.
I think I'm coming back either Monday or Tuesday.
Okay, awesome.
So.
Okay, we'll go with that. So I will try to scan your homework back to you if you want to put a note on that when you scan me. If you scan me before I send your homework back, because I'm not going to go back to my office till about 3:30. But
Okay, so
anyway,
do you want me to sign that and scan it back to you, like now?
dated December 18th last year is fine, or don't date it. I'll put the date on it. It doesn't matter. I just need it back. I just need to submit it to DMAC
Okay,
because.
do you need it
Yeah.
now, or can I hand it to you in like on Monday?
Yeah, you could. Yeah, that's fine. I might just have you sign the one I got. That's fine. It
Okay.
doesn't, don't worry about it. Yep, I got time on it. I'll just say you were out, weren't at class, but I'll have you sign it and then I'll have it anyway. Okay,
Okay,
perfect.
thank
Yeah.
you. See ya.
Yep, bye.